A randomized block design is an experiment when the experimenter divides subjects into subgroups called blocks. In this PowerPoint, I'll be focusing my subject on randomized block experiments. In this first slide, the representation explains how the randomized block experiment is divided into subgroups. The compartment is a single block on the visual, the block of compartment is a column, the battery is the equivalent as the entire block. It is important to note that the battery holds the compartment. This sets up the basis of the randomized block experiment. Here, you can see that each block within the arrow defines a sample set of subjects, which then is defined from the independent variable and the blocking variable. Then, the blocks are put through a randomization factor to remove out of experiment factors. This is an important part of the randomized block experiment, as the point is to minimize the nuisance variable. Nuisance variables are factors that may affect the measured results but are not a primary instance. For example, in applying a treatment, nuisance factors might be the specific operator who prepared the treatment or the room temperature. The nuisance factor happens in all types of experiments, and the blocking technique minimizes or eliminates the contribution the nuisance factor has on the experiment. The concepts of blocking can be defined as the creation of homogeneous blocks in which the nuisance factors are held constant and the factor of interest is allowed to vary. This slide covers how the randomized block experiment can be used in engineering. This source is from NIST. Suppose engineers at a semiconductor manufacturing facility want to test whether different wafer implant material dosages have a significant effect on the resistivity measurements after the diffusion process taking place in a furnace. They have 4 different dosages they want to try, and enough experimental wafers from the same lot to run 3 wafers at each of the dosages. Here, the engineers would use a randomized block design to eliminate the nuisance factor, which they know is the furnace run, since they know that each furnace run differs and heats differently than the last. The blocked way to run this experiment would be to put 4 wafers with different dosages in each of 3 furnace runs. The only randomization would be choosing which of the 3 wafers with dosage 1 would go into furnace run 1, and similarly for the wafers with dosages 2, 3, and 4. Advantages that the design holds is that it works with any number of treatments and blocking variables, and an effective blocking variable can provide more precision. Disadvantages may include the use of an ineffective blocking variable, which will cause the design to be less accurate, and when the experiment has too many treatment levels, it can be hard to form homogeneous blocks.